In this short video, we're going to go through the questions and answers on page 69 and 70 of the chemistry booklet. Ethene is used to make polyethylene, and polyethylene is used to make plastic bags. The table below shows the data from a life cycle assessment for a plastic bag and a paper bag, and it gives us information about things like the materials used, the energy, the mass of solid waste and CO2 that's produced, and the volume of fresh water that's used. It gives us a statement that a life cycle assessment shows that using plastic bags has less environmental impact than using paper bags, and you need to evaluate this statement using your knowledge and the information from the table above. When answering these types of questions, you always want to think about an advantage and a disadvantage for each type, and then coming up with a conclusion. So advantages that we could draw about plastic bags is they require less energy to manufacture. You can see this in the table, it only provides 1.5 megajoules compared to 1.7 megajoules for the paper bag. Advantages for the paper bag include the fact that it's made from a renewable resource, which is wood, and again we can see this in the table, that they're biodegradable, which we're using our own knowledge to provide, and that the CO2 created by paper bags can be offset by photosynthesis in growing wood, as we're using a bioresource. The disadvantages for plastic bags are they're made from a finite resource, which is crude oil or natural gas. Again, it tells us this in the table, and we're using our own knowledge to draw those conclusions. The disadvantages for paper bags is that they produce more waste, and again we can see that in the table. They create more CO2, and again we can see that in the table with 0.53 kilograms compared to 0.23 for plastic bags. They require much more fresh water, and that's significant amounts more, and also that they cannot be recycled. In question 2 is copper-rich ores are running out. New ways of extracting copper from low-grade ores are being researched. Recycling copper may be better than extracting it from its ores, and we need to explain why. For this, we might want to give reasons for and against. For recycling, it could be that there'll be less acid rain caused because there'll be less pollution, that our copper reserves will last longer because we're not mining, we're using some of that we're recycling, that the energy for extraction is saved, that there's less mining and quarrying, and therefore there's going to be less waste. If we were looking at the other side, which is probably a bit more tricky, against recycling, we could talk about the fact there would be collection problems and transport problems of getting that copper to where it needs to be, and that it can be difficult to separate copper from those appliances. In this longer answer question, it gives us some information about copper. It tells us that the world demand for copper in 2014 was about 22 million tonnes, and that the world reserves of copper are about 700 million tonnes. This is the amount of copper that we actually have available to us. Most of the copper today we obtain from copper ore, and it's mined. It tells us that the copper ore is heated in a furnace to produce copper sulfide, and the furnace is heated by burning fossil fuels. Air is blown through the hot copper sulfide to produce copper and sulfur dioxide. Some copper can be extracted from low-grade ores by phytomining. Phytomining uses plants to absorb copper compounds. The plants are then burned, and copper is extracted from the ashes. And a scientist states that more copper should be extracted by phytomining. We need to use the information to justify the scientist's statement. So we can think about this from a range of ideas. So for example, we can think from a resource-based idea, that if we are extracting from lower grade ores, and we're recycling that copper and getting rid of it, it's going to keep those supplies of ores for longer. We're going to have more of it. And also, if we're less focused on old-scale mining and using more mining, more phytomining, then it's going to, we're going to use less fossil fuels and less energy. And also, if we're using less fuel, it'll be lower cost. We can also think about it from a land pollution idea. If we're doing traditional mining, it's going to scar the landscape. There's going to be lots of noise pollution from the heavy machinery, and it will destroy the wildlife and the habitats that live there. Also, we're going to need to be producing less waste, so we're going to be producing like rocks, etc., and therefore we're going to be less going into landfill and less for waste. We can also think about an atmospheric pollution side. Burning of fossil fuels, which it tells us that we're doing in the question, produces carbon dioxide and other greenhouse gases, and that will go on to cause global warming and climate change. It also tells us in the question that extraction can produce sulfur dioxide, and we know that sulfur dioxide can cause acid rain, and that can go on to kill trees or fish and pollute waterways. So therefore phytomining would reduce these issues. In the fourth question, it tells us that aluminium is used for kitchen foil. The diagram shows a symbol on the box of kitchen foil. The symbol means that aluminium can be recycled, and it doesn't show the correct symbol for aluminium. In the first question, we've simply got to give the correct chemical symbol for aluminium. Nice and easy with the periodic table. We can look it up if we don't know it already, which is Al. We also need to give 2 reasons why aluminium should be recycled. Again, there's a range of ideas. Again, we know that aluminium as a metal is a limited resource, and so therefore we want to recycle it as we will run out. It also requires a lot of energy to extract, and so if we're recycling, we can save some of that energy. And also the mining of aluminium will have a negative effect on the environment, some of the things that we've looked at earlier.